Um, Today's assignment shouldn't be too difficult, but in my opinion, they have put this set of problems on the wrong section. But whatever, we're just going to do it. Uh, the section doesn't actually talk about inverses, but I'm going to talk about inverses. What does it mean to be a mathematical inverse? The opposite. And there are a lot of different ways to look at inverses. So let's start with what we call the additive inverse. And an additive inverse is the opposite version of any number with respect to addition. So if I give you the number 6, what is its additive inverse? That would be its multiplicative inverse. Well, in order to do this, we need to know what opposite means. And I'm talking about addition here. So an additive inverse would be 6 plus something that equals what we call nothing. But we don't really call it nothing. We call it the identity. The identity, which in this case is 0. 6 plus what number is 0? Negative 6. Okay, so 6 and negative 6 are inverses, and you have to say inverses with respect to addition. Okay, now something really cool happens with the identity. The identity is this really neat topic in mathematics, and it has a lot of properties. The first property is if you take anything and you combine it with its inverse, you get what is called the identity. But the identity also has this aspect. 6 plus the identity equals 6 every time. Okay? And is 6 plus 0 equal to 6? Yeah. And the identity is its own inverse. So if I take the identity 0 and I add it to itself, I get itself, which is 0. So the identity essentially doesn't do anything with respect to addition. Okay? And any element combined with its inverse is the identity. Anything plus the identity is equal to itself, and the identity is its own inverse. It's the only number you can add to itself and get the identity. Okay? What if we switch to multiplication? And I said 6 times something is equal to, what is nothing in multiplication? 1, right? 6 times what equals 1? 1/6. That is the multiplicative inverse. And whenever you combine any element and its inverse, you end up with the identity. And let's check to make sure that is the identity. 6 times what equals 6? 1. And is 1 times 1 equal to itself? Yes. So when we solve equations and we're moving stuff from one side to the other, we always do the inverse. The opposite of times by 6 is divide by 6. The opposite of subtract 6 is add 6. And when we do that, we leave nothing on the other side. But that nothing is sometimes 0 if you're adding and subtracting, and it's sometimes 1 if you are multiplying or dividing. Okay? Well, we're going to look at function inverse. Okay? So if we looked at a function, and I've done this before, Kyson lives in Orangeville, and Bailey lives in Castledale, and Aurora lives in Farron. Okay, we'll call this function g. What would the inverse function look like? And we're going to call it g inverse. That's going to take Orangeville and turn it back into Kyson, and Castledale and turn it back into Bailey, and Farron and turn it back into Aurora. Okay? Well, if I take one function and combine it with its inverse, what's going to happen? Nothing, right? If I daisy chain these together, so I'm going to take this and slide it over here, then Kyson gets turned into Orangeville, but then gets turned back into Kyson. Okay? So what is the identity function? What equation doesn't do anything? No, this is a little bit tricky until you see it, and then you're going to be, oh, duh. What function takes Kyson and turns him back into Kyson? What function has an input that is always equal to its output? Y equals X. Or it should be f of x equals x. So if I do f of 4, what answer do I get? 4. And I didn't do anything. 4, x equals 4, turned into y equals 4, which is exactly what we had before. So we're going to be checking today to see if two functions are inverses. And this is not an additive inverse. We're not adding things together. It's not subtraction or multiplication or division. It's function composition. Okay? So what we're going to do is I have g of x and I have g inverse of x. I'm going to be putting this function inside that function. And the result should be x, because this is the function that doesn't actually do anything. The inputs and the outputs are exactly the same. So let's say I had f of x equals 2x minus 4. And does it do inverse or does it do g of x? G of x. G of x is going to equal x minus 4 over 2. Okay? These functions are actually inverses. And again, this section doesn't talk at all about inverses. What it says is, show that f of g of x is equal to x. And then it doesn't explain why that's important. But in the next section, it will become a little bit more important. How do I perform f of g of x? What do I do? I take g of x. Oh, this should be a plus 4. Sorry. I take g of x and I stick it into the x for f of x. I'm going to put it right there. So 2 times x plus 4 over 2 minus 4. Everybody understand that? Well, this 2 cancels that 2. And I'm left with x plus 4 minus 4. But those 4's cancel. And I'm just left with x. Why is that important? Well, it proves that the first function and the second function are inverses. Okay, and again, it doesn't mention that in this section, but that's what they're trying to show you. So basically, this function here takes people and connects them to their city. Okay? And then this function takes cities and connects them back to those same people. So if I put them together, and I take people and convert them into cities, and then take the cities and convert them back to people, then this step pretty much just cancels itself out, and we end up with people get turned into the exact same people, which is why the answer was X. Okay. Now, what if I did 5 plus what equals 0? What would the answer be? 5 plus what is 0? Negative 5. Okay. What if I did it in the reverse order? What if I said negative 5 plus what is 0? The answer would be 5, and it works both ways. 5 plus negative 5 is 0, and if I switch them, 0 and negative 5 plus 5 is also 0. So I should be able to switch this and get the same result, and that's what the book wants you to do. So this time, oops, I erased my g of x. Sorry. Oh, wow, I really messed up. Okay. So now I want to do g of f of x, and I want to show that that is exactly the same thing. Okay, so I'm going to take this and put it in here, and I get 2x minus 4 plus 4 over 2. Well, the 4's cancel, and I'm left with 2x over 2, and the 2's cancel, and I'm left with x. Okay. So if you look at this assignment, it says show that f of g of x is equal to x and g of f of x is equal to x. And you're just plugging one function into the other, and everything's going to cancel. Now, on 53, there's a domain, and it says as long as x is greater than or equal to 1. Well, that has to be true because the f of x function has a domain restriction. Okay, so that domain restriction is just going to be carried on into the result. Yeah. Maybe we want to, what's the next piece of this? Because this is a super easy assignment. Um, let's also do 81. I'm going to change this to 81 to 90 all. Okay. Okay. Get to work. I wouldn't even worry about it.